Welcome, AP Calculus, to this lesson of limits. This is section 2.2. We're going to introduce the concept of limits to you guys. And so what a limit is we're trying to figure out what y value are we approaching. So we're going to be given an algebraic problem, like a calculus problem. We're going to be given a graph. And we're just trying to figure out like what y value are we going towards. So here's your example. Let's say you're given the equation y equals 2x minus 1. And the question is, what is the value of y when x is approaching 3? So that's our question. We're trying to figure out what is the value of y when x is approaching 3. So if we were to do this numerically, we're going to be using a table to do this. So let's go ahead and pull up a little table for us. Here's your x. Here's your f of x, which is your y value. And we're just going to make some lines for our table. And so we're wondering what happens as you get close to the number 3. So let's say the number 3 is right here. X approaches 3. Let's say this is the number 3. What happens as you get close to 3? Well, from the left side, you're at 1. From the left side of 3, you're possibly on the number line, you're possibly at 2. But as you get close to 3, so let's say you're at 2. Let's say you're at 2. A number closer to 3 would possibly be 2.5. And a number closer to 3 could be 2.9. And perhaps 2.99. So we're getting closer to 3 from the left side. So we're approaching 3 from the left. So here we could say x approaches 3 from the left. From the left. Now we could also approach 3 from the right side. So think of a number that's on the right side of 3. So maybe 4. So I'm going to say the number 4. And if I want to get close to 3, then maybe I'll eventually approach 3.5. And perhaps I'll get closer to 3 and I'll be at 3.01. And maybe even 3.001. So I'm getting close to 3. Now the question is, what is the y value going towards? What is the y value approaching? So there's a couple ways to do this. I'm going to share my screen so we can begin to use the TI calculator. And on the TI calculator, what I'm going to do basically, so I'm writing here on the this blackboard, and I'll transition to the calculator. What I'm going to do is I'll be able to take my function. So in this case, my function, I know it says y equals, so let me just put an equal sign and put f of x. My function is 2x minus 1. Since my function, f of x, is 2x minus 1, I could put in a number for x, 2 for example, and evaluate it. So 2 times 2 is 4, because x is 2. So 2 times 2 is 4. 4 minus 1 is 3. So that will be my result that I would put right here, 3. So the TI calculator could calculate all of these values for us. And I'm going to show you how to do that right now. So I'm going to share my screen. So here's my TI calculator. And what I want to show you is, in order to quickly spit out answers, we're going to write our equation for y1. So it's 2x minus 1. Again, the X button is next to alpha. The X button is right there. Then I'm going to press enter. And if I were to graph it, that's the equation of the line we're looking at. 2x minus 1. Go back to y equals. There's our equation. So notice how our equation is stored as y1. To quickly pull up that equation, I'm going to quit this screen. So I'm going to quit at second mode. To quickly go to the y1 equation, I'm going to press alpha, green button, F4. F4 will allow us to get any of these equations. So I'm using y1, so I'm going to press enter, parentheses. So if I, as we did in the notes, plug in a number for x, let's say I want to plug in 2.9. That'll be my y value that I'm approaching towards. And I could do it again, alpha F4, and press enter. I could plug in 2.5. But the whole point of this is get close to 3. So I want to get close to 3 as possible. So alpha F4, enter, parentheses, I could say 2.99. And I could do that one more time. Alpha F4, press enter, parentheses, 2.999. So as I approach 3, as x approaches 3 from the left side, I'm getting closer to a 4.99 number, which is, we could say it's 5. Now from the right side, I could do the same thing. Alpha F4, enter. And this is a nice feature because it allows us to quickly get an answer for some more complicated functions. So if I want to get close to 3, but from the right side, perhaps I'm at 4. Okay, I'm at 7. Another way to do this is to also just use the up arrow, highlight your text, press enter, and just change the number. So instead of 4, I'm going to say 3.5, enter. I could go up arrow again, press enter. Instead of 3.5, I could say 3.1, enter. And I'll do that one more time, up arrow, 3.01. And sometimes you don't need that parentheses in there, and it'll still give you the answer. So as you see, as I'm getting closer and closer and closer to 3, as x approaches 3, I'm approaching the y value of 5. Let's put a whole bunch of zeros and see what happens. I'm approaching the y value of 5. So that is what we see numerically, right? We're using a table. We're trying to get these answers. Let's go back to our table and just fill in so you get to see how the table looks like. Share screen. All right, so when we had 2.5, let's see if I can quickly pull that up. We had a y value of 4. So I'm just going to write 4 in here. When we had 2.9 as our value, we had 4.8 for y. When x was 2.99, the y value was 4.98. Now from the right side, when x was 4, we were at 7. When x was 3.5, we were at 6. When x was 3.01, we were at 5.02. And when x was 3.001, I didn't calculate that one, but let me just do that quickly on my calculator. Let me see. .001, enter. We're at 5.2 zeros and a 2. So as you see, f of x, the y values, f of x is approaching 5. Likewise, from the left of 3, we're approaching 5. From the left, we're also approaching 5. F of x is approaching 5. Approaching 5. So that's looking at limits numerically. We're using a table. We're crunching these numbers. That takes a lot of time. So there are easier ways to do this. And so another way to do this is to look at a graph. So now I'm going to share my screen. So you get to see a graph. So basically what we did is we had this equation, right? F of x equals 2x minus 1. This linear equation. Now from the left side, as I get close to 3 as x, so you can look at the coordinates. As x gets closer to 3, we are approaching, right, somewhere there, the y value of 5. And now from the right side, as you get closer and closer and closer to 3, so 4.1, 3.9, we're getting closer to 3, 3.5, 3.4, 3.3. From the right side, you're also approaching that same y value. And that's the goal of the lesson. What y value are we approaching? The y value is 5. So that's graphically. Share screen. Going back to our notes. All right, so let's move on. So in our next example, we have evaluate, x cubed minus 1 all over x minus 1 as x approaches 1. Oh, it's the limit problem. Let me fix this. Sorry, you guys. We're talking about limits. So I got to fix this. We got to make sure we put the LIM. That's what we're doing here. All right, here we go. Evaluate the limit of x cubed minus 1 x minus 1 as x approaches 1. So this is calculus notation. We're approaching 1. We're trying to find the limit. We're trying to find the y value. So LIM represents limit. So we're trying to find the y value. Again, you could do this by a table. So we're going to do this very quickly with a table. It's probably the last one we do with the table because it just takes too long. So we're approaching 1. So here's x. Here's f of x. Draw a line. Okay. So we're gonna plug in the number 1. Let's place 1 in here. 1 x approaches 1. So here's 1. We're trying to figure out what's the y value. What are we approaching? There's a little box. What are we approaching? So here we go. From the left side, you could be at 0, but you want to get as close to 1 as possible. And that number is 0.9. 90 cents is close to $1, but 99 cents, 0.99 is even closer to 1. From the right side, you could be at 2, but closer to 1 could be $1.50, 1.5, or 1.01, or 1.001, or 1.0001. So there's these ways to get closer and closer to a certain number. So now we got to figure out what y value are we approaching. So I'm going to share my screen again, and I'm going to try to crunch these numbers out quickly using the TI calculator. And so for some of these, I have answers to, so I'm just going to fill them in. So this is 3, 0.003. This is 3.030. 2.970. 2.710. I'm going to share my screen. So we still got to figure out 0. We still got to figure out 1.0001. And we still got to figure out a 2. What happens when x is 2? What are we approaching? So let's share our screen. We're typing in a new equation. So you go to y equals. You could go to y2 if you like. Our equation has a fraction in it. So to get fractions into your TI calculator, you need to go to F1, that little green button, F1. So you go to alpha, y equals, numerator, denominator. Press enter. There's our fraction. And we want to type x cubed minus 1. So we know where x is. This caret sign, little up arrow, that's to the power of 3. Go forward with the right arrow, minus 1. On the bottom, that was the down arrow. To go to the bottom, down arrow is x minus 1. Press enter. Now that's y2. That's our equation, y2. So I'm going to quit the screen by pressing second mode. That's quit blue. And I'm on y2. So you press alpha, F4. Number 2, I just click down arrow to go to 2 and press enter. Parentheses, I wanted to figure out what happens when x was 0. That's what I get. I want to know what happens when the x value was 1.0, 3 zeros and a 1. And lastly, what happens when x was 2? So we're going to delete all this when x was 2. So now let's go back to stop sharing. I'm going to share my screen here. So when x was 2, we had 7 as our answer. When x was 1.0001, we had 3.0003. And when x was 0, we had a number 1. So from the right side, we're approaching a y value of 3. Likewise, from the left side, 2.9, wouldn't you say that's very close to the number 3? So the answer for this problem, when you have this type of limit problem, you're going to say the answer is 3. We're approaching the y value of 3. That's your answer. That's your limit. All right, next example. Example. Sorry for the little dots. That's just my palm resting on the screen. And it produces those little dots. X, so the limit of x over radical x plus 1 minus 1 as x approaches 0. We're trying to figure out what is that limit equal to. So for this problem, we're going to show you graphically what that is. So I'm going to go to the h function. So our question was, we had this x divided by radical x plus 1 minus 1. We're trying to figure out what happens as x approaches 0. So from the right side, as you get closer and closer and closer to 0, what happens? Well, you're approaching the y value of, take a guess. What is that y value? 2, right? What about from the left side? The y value is 1, 1.3, 1.5. As you get closer to 2, 1.8. And we would say you're approaching 2. But when you're so close to the x value of 0, as you get closer to the x value of 0, the y value is not 2, it's undefined. Why do you think that is? Why do you think we have an undefined answer and not 2? And so the answer to that is when you're evaluating a function, so this is our function, if you go ahead and plug in 0 in here, so if you have 0 plus 1, that's 1. Square root of 1 is 1. 1 minus 1 is 0. You can't have a 0 on a denominator of a fraction because that's undefined. Can't determine that answer. Well, let's just say it's undefined. It's an undefined fraction. So that's why we're getting this undefined situation here. But with limits, with calculus, we're just trying to figure out what are you approaching both from the left side, what are you getting towards, and from the right side, what are you approaching? That's basically it. We are approaching that y value of 2. And both from the left and from the right, it looks like it's going to the same place. All right, share screen. Let's go back to our notes. So we said we're approaching 2, the y value of 2. All right, that's it for the lesson. I do have a couple more examples for you, but I'm gonna talk about that in class just so I could record this video, put it on YouTube for y'all. I wanna mention just really quick some things that we talked about in terms of limits. We started talking about how to compute limits. And in this lesson, we were looking at how to find limits numerically, using that table, crunching numbers out, using our calculator. So basically, we were using a table. Number 2, we looked at limits with a graph. It's kind of nice having that picture, right? With a graph. And number 3, which is our next lesson, how to find limits algebraically, using algebra. Who doesn't like algebra? That's algebra 1. We could do that. All right. Thank you guys for checking in. See you at the next video.